Hi friends, today we will be starting about fluid mechanics in our first year intermediate physics, that is, it is also called as mechanical properties of fluids. Okay, so today's topic is mechanical properties of fluids. This is also called as fluid mechanics. This is also called as fluid mechanics. So, first of all, what is meant by fluid mechanics or mechanical properties of fluids? That means fluids under the action of forces. Forces in the sense gravitational forces, okay, or the fluid at rest. When the fluid is in motion or the fluid at rest, the study about the fluids, the fluid in motion or the fluid at rest, okay, the study of the fluids is called as fluid mechanics, just like dynamics. Dynamics మనం చదివాం already. What is dynamics? Under the action of external forces, the study about the bodies, mathematical and physical study. So here we will be studying about the fluids motion. Okay? It may be at rest or it may be in motion. That chapter is called as mechanical properties of fluids or fluid mechanics. Okay? Right. Now, first of all, in this chapter, I want to tell you 90% will be assuming 90% will be assuming as imaginary fluid. That means ideal fluid. What is meant by ideal? Generally, in general, ideal fluid will not be there. Only for some derivation purpose or in doing some numericals will be adopting this ideal. Ideal and a mat undadu actually. Like ideal gases. It is only imaginary one. Okay? So first of all, let us know what is meant by ideal fluids. In general, fluids are real, ideal. In general, fluids in rakalu, real fluids, ideal fluids. But in this chapter, maximum 90% above will be considering for all derivations and assumptions as a ideal fluid and imaginary fluid. So first of all, let us deal what is ideal and then we will go for real fluids. See, ideal fluid means what? The fluid is non-viscous. That means it doesn't have any frictional forces or viscous forces. It has no frictional forces. Frictional forces between the layers. That is meant by non-viscous. Okay? Irrotational. That means it is not turbulent. It doesn't have any angular velocity omega. Okay, it is not turbulent. It is laminar, irrotational. Incompressible fluid. So incompressible and density is remaining constant. Whatever point you take, density is constant. So ideal fluid is nothing but it is non-frictional. That means doesn't have any frictional force between the layers. That is non-viscous. In the same way, irrotational. Okay? It doesn't have any omega and incompressible. Density is constant at anywhere if you take the cross section. That fluid is called as an ideal fluid. It is an imaginary, it doesn't have in real life. Now coming to what is real fluid. See, what is real? If any fluid is flowing on any surface, it has friction. Okay? Friction. So those fluids will have frictional forces between the layers are called as real fluids. Okay? Now this one we will be studying rarely in the last topic of this chapter. But now we will be considering only imaginary fluid, that is ideal fluid. Clear? Okay. Please note down. We will go to the next point in this one. Right? See here. Now, as I said just now, fluid is real and ideal fluid. For example, now let us study, suppose when fluid is in motion. Suppose let the fluid is in motion. Suppose the fluid is in motion. For example, I will consider some layers. I will consider some layers of fluid. This is ground surface. These are some layers of the fluids. For example, these are some layers. These are some layers. So when the layers of fluid are going, we have one derivation intermediate. That is, according to Newton, the viscous forces, because this is a real fluid here. Here it is not an ideal, it is real fluid. Just now I told you when any fluid is real, it will have frictional forces. So according to Newton's laws of viscous forces, frictional force will be acting in opposite direction between the layers of the fluid. So ఇక్కడ ఏం చేస్తాను నేను, I will consider any two layers. For example, AB, CD. I will consider two layers, that is AB and CD. Let us consider for derivation. Let this AB is moving with velocity V plus delta V, and let this CD is moving with velocity V. Let this CD is moving with velocity V. Okay? Now, not only that, this is, for example, displacement x, and this is x plus delta x with the ground. Now this fluid is going in this direction. This is the direction of flow. This is direction of flow. Now according to Newton's laws of viscous forces, force will be in opposite direction between the layers because the real fluid is not an ideal. So appudu em avutundi, according to this viscous force directly proportional to, because it is in opposite direction, I will put minus, directly proportional to the velocity gradient, and it is also directly proportional to the area of cross section of the fluid. Okay? Now we combine both the equation, minus f proportional to A delta V by delta x. I will take minus this side and remove the proportional and introduce a constant K delta V by delta x. Now observe carefully, why I have taken negative sign, because viscous force are acting in opposite direction. Okay? So this K here I will call it as eta. ఈ K ని ఏమంటాం మనం? It is called as eta. Constant of proportionality. It is also called as coefficient of viscosity. దీని ఏమనొచ్చు? Coefficient of viscosity or coefficient of dynamic viscosity or coefficient of dynamic viscosity. Clear? Now put that one here. F is equal to minus eta A delta V by delta x. This is the formula for viscous forces when the fluid is in motion for real fluid. Coefficient of viscosity or coefficient of dynamic viscosity, A, area of the cross section of the fluid, delta V by delta x is the velocity gradient. Now we will try to study what is velocity gradient in its SI units and also coefficient of viscosity its SI units. Let us study. Now let us see what is velocity gradient and the units. Okay? Now velocity gradient and enti delta V by delta x. Just now I told you delta V by delta x I am calling as velocity gradient. So what will be the units? Velocity gradient means velocity acting perpendicular to the displacement of the fluid. That is called as velocity gradient. So velocity units, what are the units? Meter per second by meter. That is, see, meter per second, and displacement enti meters into 1 by meter. So second inverse. So velocity gradient, what is the SI unit? Second inverse. Velocity unit is meter per second by displacement by meters. Meter cancel, 1 by second or second inverse. This is the unit for velocity gradient. Now let us give the units for coefficient of viscosity. See, coefficient of viscosity units and SI units కనిపెడదాం. చూడండి, force into delta x by A delta V is equal to eta. And this eta I am telling as coefficient of viscosity with coefficient of dynamic viscosity. Force newtons, displacement meter, area meter square, velocity meter per second. Second పైకి వెళ్ళిపోతుంది. Meter get cancel. Newton second per meter square. So the SI unit of coefficient of viscosity eta is given by Newton second per meter square. Please note down, very important. In bit examinations, bit questions in INSET and also in IP also they are asking regularly what are the SI units for eta. Now let us go further. Clear? Right. Even you can write the dimension formula also if you want. You can put the values and you can write the dimension formula. Student, you can even write the dimension formula for eta. See, what is force? F delta x by A delta V. For this you can write dimension formula. Force enti MA ml t power minus 2 into displacement L by area L into L square. Velocity, rate of displacement into L by T. Okay, this L square cancel. Now what is left over? M power 1, L power minus 1, T power minus 1. Clear? T power 1, T power minus 2 anta? T power minus 1 plus 1 minus 2 minus 1. So M power 1, L power minus 1, T power minus 1 is the dimension formula for coefficient of viscosity. Like this you can find out. First know the concept. See, concept is very important. If you know the concept, you can write any dimension formula for any physical quantities. Okay. Now let us go further. Just now I told you regarding coefficient of viscosity units. What are the units? Newton second per meter square. So here, watch carefully. Newton second per meter square, I told you as SI unit. Okay, this is SI unit. SI unit of eta. The same thing, Newton second per meter square, you can write in CGS. The CGS is in the place of Newton, I'll write it as dynes second per meter badalu cm square. So this is the CGS unit, and this is also called as 1 poise. It is named after the scientist Poiseuille. Okay, this 1 poise, it is named after the scientist Poiseuille. Okay. Now let us find the relation between SI unit and CGS unit. Relation between SI and CGS unit for eta. Let us find out. This is also 2 marks derivation IPE. Okay. Let us find the relation between SI unit ki CGS unit relation ante chuddam. Now let us see. SI unit enti Newton second per meter square. This one I can write as what is 1 Newton from units and dimensions. 1 Newton is equal to 10 power 5 dynes, I told you in the first chapter. So in the place of Newton I can write 10 power 5 dynes. Second I'll write meters. We know 1 meter is equal to how many centimeters? 100 centimeters. Therefore 100 centimeters whole square. Therefore Newton second per meter square is equal to 10 power 5 dynes into second by 100 centimeter whole square. ఎంత అవుతుంది? 100 into 100 centimeter into centimeter, 10 power 4 cm square. 10 power 4 5 లో cancel అయిపోతే 110 is left over. 10 into what is dyne second per cm square? Here dyne second per cm square is equal to 1 poise, named of the scientist Poiseuille. So I can write as 1 poise. Therefore from here you can see Newton second per meter square is equal to 1 poise. 10 poise. And from this, what is 1 poise? Take 10 down and take to the numerator. Therefore from this 1 poise is nothing but 10 to the power of minus 1 Newton second per meter square. Very important derivation. 1 poise is equal to how much? Take 10 to the denominator P and take it to the numerator. 10 to the power of minus 1 Newton second per meter square. Very important derivation and ఇది note చేసుకోండి. Sometimes he may be asking for 2 marks, or I think maximum 2 marks or not 4 marks. You may ask for only 2 marks. Okay, clear? Right. Now let us go to the next point in this version. So just now we are talking about real fluids and imaginary fluids. Now because it is a real fluid, we have a frictional force. So therefore that frictional force is nothing but, according to Newton, that is frictional force is nothing but viscous force according to Newton. It is viscous force. So we have got one term, that is eta. Now let us learn one more term, second term, that is coefficient of kinematic viscosity. Next thing is coefficient of kinematic viscosity. Coefficient of kinematic viscosity. Entity simple definition, it is indicated with the letter mu. This is eta by rho. It is the ratio of coefficient of viscosity or coefficient of dynamic viscosity to that of its density of the fluid. So therefore units ఏంటి mu ki already the units ఏంటి SI Newton second per meter square. Okay, Newton second per meter. Density ఏంటి kg per meter cube, kg per meter cube. Therefore Newton second per meter square into meter cube per kg. But you should not put like this. We have a standard unit. 1 Newton according to force, you know, F is equal to ma. What is 1 Newton? Kg meter per second square is nothing but 1 Newton. So put it here in the place of 1 Newton. Kg meter per second square into second by meter square into meter cube by kg. Kg. Okay. Second. Meter into meter cube. So I will cancel meter square and here 1 meter. 1 meter is left over. Meter into meter square per kindana oka second migilindi. So therefore, what is the unit of coefficient of kinematic viscosity mu SI unit or MK meter square per second? This is MKS or SI unit. Or simply you can call it as, sometimes both are same only. SI unit means, you know, scientist names. Okay, if scientist name is not there, you can call it as MKS. This is unit for MKS unit. In the same way, what is CGS unit? Directly connected, meter place lo centimeters, cm square per second. This is CGS unit. CGS unit of mu. That is coefficient of kinematic viscosity. Please note down, these are very, very important terms because in the examination they are asking regularly. Clear? Right. Now, after learning about coefficient of viscosity or dynamic viscosity, coefficient of kinematic viscosity, okay? So you may be wondering what is viscosity. So viscosity and then it is a property of the fluids. Okay? It is a property, viscosity, property of the fluid. That means it is acting between the layers of the fluid when it is in motion. Just like frictional force. Viscosity and it is the property of the fluids. Okay? When the fluids are in motion. Right. Now let us go further. After learning about these two terms. Yes. One more thing also they are asking in the examination. Relation for MKS and CGS for mu. Coefficient of kinematic viscosity relation అడుగుతాడు. MKS units ఏం చెప్పాను ఇందాక? మీటర్ స్క్వేర్ పర్ సెకండ్. అలాగే CGS ఏంటి? సెంటీమీటర్ పర్ సెకండ్. They are asking relation. Now let us try the relation. Meter square per second, I can write it as, what is 1 meter? 1 meter is nothing but 100 centimeter. Therefore, 100 centimeter whole square by second. Therefore, meter square per second, this one how much I can write? 100 square, that is 10 power 4 cm square by second. But cm square per second is equal to what? Okay, cm square per second, I can also call it as, please make a note, cm square, the CGS is also called as Stoke. After the scientist Stoke. So cm square per second CGS unit is also called as 1 Stoke. It is named after scientist Stoke. So put it here. Meter square per second is equal to 10 power 4. Cm square per second is equal to called as Stoke. Okay? Clear? So here, how can you write this one? See here, meter square per second is nothing but 100 centimeter whole square per second. That is nothing but how much? 10 power 4 Stokes. So from this, what is 1 Stoke? 1 Stoke. See, 1 Stoke, can you just by this calculation? 10 to the power of minus 4, okay, meter square per second is equal to 1 Stoke. Very, very important. In the examination, they are asking regularly. Relation between mu, relation for mu for MKS and CGS units. In MKS, the units just now are derived, that is meter square per second, and CGS it is written as centimeters per second. And if you put the values here, 1 meter is 100 centimeter whole square, okay, by second. So therefore, meter square per second is equal to 10 power 4 cm square per second. Cm square per second is equal to 1 Stoke. Therefore, from this 1 Stoke is equal to 10 to the power of minus 4 meter square per second. Please note down. Very, very, very important derivations regarding examination. Now let us go further in this chapter, fluid mechanics, that is mechanical properties of the fluids. Very, very important things. Okay, these all are very, very important. Now let us go, as we are studying about real fluids and imaginary fluids. Now let us see what is meant by laminar flow. Okay, let us see what is meant by laminar, steady or streamline flow. ఈ మూడు మీనింగ్స్ ఒకటే. Okay, now for example, see here, this is a tube. Suppose from this water is flowing, for example, so this is fluid, water. Okay, fluid. Now when the water is flowing, for example, if you take any cross section at any point, okay, if the velocity remains constant, if the velocity of the fluid remains constant with time at any point on the fluid flow, if you take the velocity at any point in the fluid flow, if it is constant, then that fluid is called as laminar flow, steady flow or streamline flow. Okay, when the fluid is flowing from any pipe, at any cross section if you take, if the velocity remaining constant with respect to time, then it is called as laminar. And suppose if the velocity is changing with the time, ఒకవేళ velocity మారితే with respect to time, that flow is called as turbulent flow. ఏమవుతుంది? Turbulent flow. If the velocity is changing, see, for example, new taps, if you can see in bathrooms or in buildings, when during construction, they will be putting taps. When the taps are very new, so water will be flowing uniformly. So such type of flow is called as a laminar flow or steady flow or streamline. Suppose for the same tap, when it becomes old or right, okay. Now you can see here we are studying about laminar and turbulent flows. Okay, we are studying about laminar and turbulent flows. Here you can observe here, if the velocity of the fluid, see here, this is a small tube, from this water is flowing. If you take at any cross section with respect to time, if the velocity right, so here you can observe this is a tube, horizontal tube. From this the fluid is flowing. So here what I am trying to tell, what is laminar and turbulent flow. In laminar flow ఏమవుతుంది? Suppose if the velocity is remaining constant with respect to time at any cross section if you take, then it is laminar flow. For new taps, water will be flowing like a laminar, steady flow. But when the taps become older and older, so the water will be flushing out like anything. Therefore, the velocity changes with time, with respect to time. If velocity changes with time at any point of the cross section, such a flow is called as turbulent flow. The best example is nothing but when floods are coming, water will be flowing like anything with different velocities at different cross sections. So that type of flow is called as turbulent flow. Clear? Right. Now let us go further. Let us go further. Okay. Now we'll do one thing. After learning about laminar and laminar study or streamline flow, let us see what is meant by Reynolds number. Very, very important in the examination. What is meant by Reynolds number? RE. ఈ రెనాల్డ్స్ నెంబర్ అంటే ఏంటి? ఎగ్జామినేషన్లో ఇవి అడుగుతున్నాడు ఈ మధ్యకాలంలో. వెరీ వెరీ ఇంపార్టెంట్. ఫర్ ఎగ్జాంపుల్, దిస్ ఇస్ ఎ ట్యాప్, this is a tube. Suppose this tube is having a length of L, say. Let the diameter be D and R be the radius. Let the density be rho and let the coefficient of viscosity of the fluid be eta. Clear? And the velocity be V. The velocity of the fluid coming out. The velocity of the fluid coming out be V. Let the fluid velocity V, radius of the tube be R, diameter D, coefficient of viscosity of the fluid is eta, and the density be rho. Now, how can you define and how can you give an equation for Reynolds number? Generally, it is given by rho V D by eta. What is the use of Reynolds number? A scientist named Reynolds has given for the flow of the fluid some numbers. He has given some value. For such a value, you can call it as laminar. When that value is, suppose, that means you have different values like 1000, less than 1000, greater than 2000, between 1000 and 2000. For different values of the fluid flow, he has named some flows like laminar flow or steady flow, unsteady flow, turbulent, like that. So the equation for Reynolds number is rho V D by eta. What does it mean? So from this it is very clear. You can see Reynolds number into eta is equal to rho V D. This V is velocity, please, not volume, velocity. Okay? Rho V into D, diameter. So from this I can write it as Reynolds number into eta by rho into D is equal to velocity. That means what does it indicate? Velocity of the fluid is directly proportional to coefficient of viscosity, and velocity of the fluid is inversely proportional to rho comma D. మీకు అర్థమవుతుందా? Velocity of the fluid coming out of the pipe is inversely proportional to density and diameter. That means more density, more diameter, less velocity. అర్థమవుతుంది మీకు? More diameter, less velocity. Certainly that is. Okay? So this is the equation you have to put it in your mind. Velocity is directly proportional to coefficient of viscosity eta. So final equation ఏమైంది మనకి? Reynolds number is given by rho V D by eta. If you substitute these values, density, velocity, diameter of the pipe and coefficient of viscosity, if suppose the Reynolds number is less than 1000 value, it is called as laminar flow or streamline. It is called as laminar flow or streamline or steady flow. If the value of Reynolds number is less than 1000, if the value of Reynolds number is greater than 2000, it is called as turbulent flow. ఏమంటారు దాన్ని? It is called as turbulent flow. అర్థమవుతుందా? So if you put the values of all the values, density of the fluid, velocity of the fluid, diameter of the pipe, coefficient of viscosity, then if you got the value as less than 1000, it is laminar, more than 2000 it is turbulent, and suppose if the value is greater than 1000, less than 2000, then that flow is called as unsteady. And it is not either a streamline or turbulent, it is between. మీకు అర్థమవుతుందా? ఒకవేళ రెనాల్డ్స్ నెంబర్ గ్రేటర్ దెన్ 1000 అయ్యండి, లెస్ దెన్ 2000 అయితే ఇట్ ఈస్ కాల్డ్ as అన్స్టడీ ఫ్లో. ఇట్ మే బి బిట్వీన్ ఇట్, అంటే యూ కెనాట్ కాల్ ఇట్ ఈస్ ఐదర్ లామినార్ ఆర్ టర్బులెన్స్. ఇట్ ఈస్ బిట్వీన్ లామినార్ అండ్ టర్బులెంట్ ఫ్లో అనమాట. నైదర్ ఇట్ ఈస్ స్టడీ ఫ్లో, స్ట్రీమ్లైన్ ఫ్లో, నార్ ఇట్ ఈస్ turbulent flow. It is between these two flows. That is called unsteady. It is called as unsteady flow. So these things are very, very important in the examination bit questions. They are asking in NEET and other examination. Please note down. Clear? Okay. Now, after learning about streamline or laminar or steady flow and turbulent flow and Reynolds number, now let us see what is meant by equation of continuity. Very, very important. Equation of continuity. What is meant by this equation of continuity? Let us study. For example, this is a tube. For example, here the area of cross section be A1, here A2. Let V1 be the velocity here and V2 be the velocity here. Suppose the fluid is flowing like this. Okay. Please make a note. Whenever I am considering such type of things, the fluid is ideal, imaginary. No viscous forces, irrotational, okay, and incompressible. Now equation of continuity and em cheptunnadu, whatever fluid entering, mass, dm mass, whatever the mass of the fluid entering at P end, same mass should come outside. This is also called as law of conservation of mass. ఎంత మాస్ అయితే ఎంటర్ అవుతుందో ఈ ఎండ్లోంచి, సేమ్ మాస్ షుడ్ కమ్ అవుట్ సైడ్. దట్ ఈస్ కాల్డ్ as ఈక్వేషన్ ఆఫ్ కంటిన్యూటీ. అంటే అర్థం ఏంటి? వాట్ ఈస్ మాస్? హౌ విల్ గెట్ డెన్సిటీ? లెట్ ద డెన్సిటీ బి హియర్ ρ1 and let here be ρ2. Because the fluid is incompressible, densities are same. So ρ1 can be equal to ρ2. So here what is density? Density is equal to mass by volume. లేదా ρ1 V1 is equal to dm. Here V1 means volume of the fluid. Here V2 means volume of the fluid coming outside. So ρ1, what is volume? Volume is equal to area into length. So A1 into L1 is equal to dm. Clear? Or ρ1 into A1, what is length? Displacement. Displacement is equal to velocity into time. Okay? Let the time be dt time, small interval of time. So ఇక్కడ L1 బదులు velocity into dt and రాసుకోవాలి. Same thing you will get here also. How much? ρ2 A2 V2 dt. So according to the law, whatever mass entering the end, same mass should come outside. That is called as equation of continuity. Therefore, whatever dm mass is here, same dm should be here. So when you equate it, what happens? ρ1 A1 V1 dt is equal to ρ2 A2 V2 dt. dt cancel, ρ1 ρ2 cancel because the fluid is incompressible. Density is constant. Therefore, what is left over? A1 V1 is equal to A2 V2, or AV is equal to constant, or A is inversely proportional to velocity. More velocity, less area. Less velocity, more area. This is the relation between area of the pipe and velocity of the pipe. And this equation, A1 V1 is equal to A2 VT, is called as equation of continuity. In the examination, this question is also asking. Please note down. Very, very important. Okay. Very, very important. Now, after learning about the equation of continuity, different types of flows, and Reynolds number, let us go a little further. See, the next one is very, very important in the examination. In IPE, they are asking for 8 marks question, derivation, and in later on MSET and NEET exam, you can apply this theorem also. This theorem is called as Bernoulli's theorem or Bernoulli's principle. This is called as Bernoulli's theorem or principle. So a scientist called Daniel Bernoulli has invented this one. He is a great mathematician and physicist. So ఈ బెర్నౌలీ అనే శాస్త్రవేత్త సైంటిస్ట్ దీన్ని ఇన్వెంట్ చేశారు. అందుకే దీన్ని బెర్నౌలీస్ థియరమ్ ఆర్ ప్రిన్సిపల్ అంటున్నారు అనమాట. Now what is this Bernoulli's theorem? Let us try to understand first of all. This derivation is very important in intermediate IPE. Let this is a tube having unequal cross section area A1, A2, velocity V1, V2, pressure P1, P2, volume V1, V2, force F1, F2. Okay? Now let this pipe, this end is at a height of H1 from the ground level. This is ground level. And let this height be H2. And it is having unequal cross section. This is the fluid flowing inside. Please make a note, I told in the beginning also, 90% and above, the fluid is treated as ideal. Fluid is treated as ideal. That is imaginary fluid, because if you treat it as real, you cannot derive Bernoulli's theorem. Okay? So in the case of Bernoulli's principle or Bernoulli's theorem derivation, the fluid should be considered as ideal, imaginary. What is imaginary? Non-viscous. That means no frictional force between the layers. Incompressible. Incompressible. That means densities are same. And irrotational. That means omega is not. That means it's a laminar flow. No turbulence. These three you have to consider. Non-viscous, incompressible, okay, and irrotational. Irrotational. Irrotational means laminar flow, no turbulence. Laminar. When you consider these 3 points only, Bernoulli's theorem can be derived. Otherwise, you cannot derive Bernoulli's theorem. Okay? A fluid ela undali? It should be laminar. Laminar ante irrotational. Omega should not be there. Rotation. Incompressible. Density should be constant anywhere. Non-viscous. No frictional force between the layers. Now let us derive this equation, very important, one by one steps. I'll tell you. I have already given the parameters here. At P end, I'll name some letter. I'll take it as M. M end, N end. At M end, I have taken parameters, pressure P1, A1, V1, velocities, area, cross-section, volume, force. And at N end, P2 pressure, V2 volume, small v2 velocity, A2 area, F2 pressure. Clear? Now I told you, when you consider these 3 points for Bernoulli's explanation theorem, non-viscous, no friction, incompressible, density constant, and irrotational, laminar flow, no turbulence. So after considering this, what you have to do? Whatever mass entering, same mass should come outside. That is dm. Law of conservation of mass. Okay? That is from equation of continuity. Mass entering, dm. dm entering should be equal to dm leaving from n end. Whatever mass is entering from m end, same mass should come out from n end. ఎంతైతే మాస్ m end నుంచి వెళ్తుందో అంతే మాస్ బయటికి రావాలి. Now let us calculate what is the mass entering. How we will get? So let us calculate the density here rho1 and here density rho2. So density here how much? Rho1 is equal to mass per volume V1. So therefore rho1 into V1 is equal to dm entering, or rho1, what is volume again? Volume is equal to area into length L1. So area A1 into length L1. But what is length? Displacement per unit time. Displacement is equal to enti? Velocity into time dt. Dt is small interval of time. Put this value here. Rho1 A1 in the place of length enti? V1 dt. This is mass entering. This is the mass of the fluid entering this end. So according to law of, conservation of mass or equation of continuity, ఏమవ్వాలి? Same mass should come outside. So ఈ end నుంచి ఎంత వస్తుంది? Same mass. ఎంత? Rho2, A2, V2, dt. this important, very very important equation 1. So according to law of conservation of mass or equation of continuity, whatever mass is entering the tube m end, same mass should come outside. This is the first thing you have to derive in the Bernoulli's theorem. Okay, note down please. We'll go to the next step. Right. So for derivation, what you have considered, I told you in the beginning only, the fluid should be laminar, and it is ideal fluid, it's not a real fluid. No frictional force should be there between the layers. And next, irrotational, that means laminar, incompressible, density is constant. So this is the first thing. I'll write it better here for the remembering. Rho1, A1, V1 dt is equal to dm entering, and is equal leaving how much? Rho2, A2, V2 dt equation 1. Now I'll go to the further derivation. Right. Now you know the fluid is entering from here, from M end, and it is coming down. That means it is flowing. The fluid is flowing and it is free fall. Nobody is pulling it. It is coming under gravity. So let us find out work done. Work done at M end. Work done by the fluid at M end. Okay? Work done by the fluid at M end. E end there ento pan chesindi work done. So I will write it as work done by the fluid at M end is equal to force into displacement. Force into displacement. Displacement ante ikkada manaku already undi kabatti adi apply cheddam. Force into, first of all em cheddam displacement L1 అని రాసేది because here I taken as L1. Okay? Now force ante ikkada enti F1 force because here force is F1. So therefore work done by the fluid at M end is equal to what is force? Ikkada pressure enta P1. So pressure is equal to force by area. P1 is equal to F1 by A1. So therefore ikkada F1 ఎంత అవుతుంది అప్పుడు P1 into A1 into displacement ఎంత అనుకున్నాం L1. So this is work done. Okay, work done by the fluid. Because ఇక్కడ దీని మీద వర్క్ ఫ్లూయిడ్ ఇక్కడ నుంచి కిందకు వస్తుంది by gravity. Nobody is pushing because the fluid is coming free fall. It is falling under gravity. So work done by the fluid. Okay, work done by the fluid. ఎంత అవుతుంది P1 A1 L1. In the same way at N end. If you apply N end ఎంత అవుతుంది again same things here. Force F2 into L2. Again what is P2? F2 by A2. So when you put it here, work done by the fluid. Work done by the fluid at N end is equal to how much? F2 into L2, same thing. P2, A2, L2. So fluid is flowing from M to N end, which is at a higher level, M or N. So M is at higher level. So this work will be more than this work. So what is net work? Net work done by the fluid from M to N end is given by, this is more because it is higher level, higher potential. This is lower potential. Okay? So therefore, ఏమవుతుంది Wm minus Wn, that is equal to work done here how much? P1 A1 L1 minus P2 A2 L2. So this is the net work done by the fluid from Mn to Nn. Now apart from this one, we have one more work. What is that work? Potential energy. What is gravitational potential energy? That is H1 and H2. So what is gravitational potential energy? Gravitational potential energy is equal to mg, which is at higher level, H1. So mg H1, okay, minus mg H2. This is at lower level. This is at higher level. So gravitational potential ఎంత అవుతుంది mg H1 minus mg H2. So total work ఇప్పుడు ఎంత అయింది మొత్తం వర్క్ ఫ్లూయిడ్ మీద? Work done by the fluid from M to N plus gravitational potential energy. Therefore P1 A1 L1 minus P2 A2 L2 plus dmg H1 minus dmg H2, and this entire work is equal to what? Because the fluid is in motion, it is equal to change in kinetic energy, is equal to change this entire work is equal to what? Delta KE. Work energy theorem. Work done by all forces, conservative and non-conservative force. Work per energy చెప్పాను మీకు. So this work P1A1L1 minus P2A2L2 plus dmgH1 minus dmgH2. This is equal to what? Change in kinetic energy, that is half m v square minus half m v1 square. Change in delta K and change in kinetic energy, final kinetic energy minus initial kinetic energy. Now this equation I'll take it as 2. This equation I'll take it as 2. Please copy it down. Very important derivation for 8 marks in intermediate. Very important. Please ask one. We'll go further now. Clear? Right. Now see here what happens. Already in equation we have derived whatever mass entering the fluid at m end and whatever mass leaving the fluid. Now what I will do, this entire equation I will divide by dm. This entire equation I will divide by dm. And entire equation 2 నేను చేస్తాను, divide by dm. Then what happens, you see, P1 A1 L1, okay, P1 A1, okay, L1 by dm. Or else we'll do one thing, okay, we'll divide d1. Here anything left over here in this equation, I think dt time we have forgot here. dt ఉంటుంది. Here dt is there because here you know what is the displacement, velocity into time. So in a time dt time and చెప్పాలి. You have forgot to write dt here. So dt is there here. Okay? Because what is displacement? Velocity into time. dt time అని చెప్పుకున్నాం. So అందుకే L1 into dt మర్చిపోయాం. Now I'll write here also dt. So when you divide entirely with the dm, what happens? See, P1 A1 L1 dt by dm minus P2 A2 L2 d2 by dm. Here dm cancels and here left over how much? Plus gh1 minus gh2 is equal to, right side kuda dm will become, because you are dividing entire equation. So dm is cancelled and finally you are left over with v2 square by 2 minus v1 square by 2. Okay? Now watch carefully from this equation. What is dt by dm? What is dt by dm? It comes down. So dt by dm from equation 1 you can take it outside. You can see dt by dm from equation 1, what happens? P1 A1 L1 by rho1 A1 V1. Okay na? Rho1 A1 V1. You have not written here V1. See here? Rho1 A1 V1. Here also you have forgot to write V1 also in the place of length. What we'll do, here V1 కూడా వస్తుందని చూడండి ఇక్కడ. In the place of length you have to write V1 into, okay, because what is length here? I'll write it there only, better. Displacement ante velocity into velocity. Okay now? So here also I'll change that one. Velocity into time. So here see, what is dm by dt or dt by dm? dt by dm ఎంత అవుతుంది? కిందకి వచ్చేస్తుంది dt by dm. See, it will come here. dt by dm 1 by. So rho1 a1 into v1 minus p2 a2 v2 dt by dm. మళ్ళీ కిందకి వచ్చేస్తుంది ఇది. dt by dm here. Both are equal, same, this and this. Okay? So here also dt is there. dt by dm. See, rho2 a2 v2 into dt is equal to dm. So dt by dm అంటే 1 by rho వస్తుంది, అంటే కిందకి వచ్చేస్తుంది 1 by, that is rho2 a2 v2 plus gh1 minus gh2 is equal to v2 square by 2 minus v1 square by 2. a1 v1 a1 v1 a2 v2 a2 v2. Now what is left over? p1 by rho1 minus p2 by rho2 plus GH1 minus GH2 is equal to V2 square by 2 by, see here, V2 square by 2 minus V1 square by 2. Please rearrange all these equations in one form. Rearrange. ఈ ఈక్వేషన్స్ అని రీఅరేంజ్ చేద్దాం మనం. మీకు అర్థమైందా? రీఅరేంజ్ చేసి చూడండి, ప్లస్లన్నీ ఒకవైపు P1 by ρ1. ఓకే, I'll take this one to left side. Plus V1 square by 2. Okay, and already plus is here. Plus GH1. This will shift to right side. రైట్ సైడ్ ఏముంది, ఆల్రెడీ మనకి మైనస్ని రైట్ సైడ్ తీసుకెళ్ళిపోదాం. అప్పుడు ఎంత అవుతుంది? P2 by ρ2 ప్లస్, ఓకే, ఆల్రెడీ ఇక్కడ V2 స్క్వేర్ ఉంది, V2 స్క్వేర్ by 2, అండ్ దిస్ ఈజ్ ఆల్సో H2 అండి. H1 మైనస్ H2 ఇది చూడండి, H2 ఇది ప్లీజ్, GH1 మైనస్ GH2, దీన్ని కూడా రైట్ సైడ్ తీసుకెళ్ళిపోదాం. ప్లస్ GH2. వాచ్ కేర్ఫుల్లీ దిస్ ఈక్వేషన్. P1 by ρ1 plus V1 square by 2 plus GH is equal to P2 by ρ2 plus V2 square by 2 plus GH2. So this equation is nothing but Bernoulli's theorem. P by rho plus V square by 2 plus GH is equal to constant. This is none other than Bernoulli's theorem, Bernoulli's principle. Divide equation entirely by G. Divide this entire equation by G. We'll see what happens. Clear all of you? Very big derivation, 8 marks derivation intermediate. Very important also. Divide this entire equation with G. Appudu em avutundi? P by rho G plus V square by 2G plus H. You are dividing. Is equal to again a constant. So this is what? This is the Bernoulli's principle in one form. The total sum of pressure head, velocity head and gravitational head or potential head is equal to a constant. Are you following the point? And finally we came to a point that is the derivation of Bernoulli's principle or Bernoulli's theorem. The total sum of that means when a fluid is in flow, when the fluid is flowing, at any point if you take the total sum of pressure head, velocity head, that is P by rho G plus velocity head V square by 2G plus gravitational head or potential head H is equal to constant. Okay, that is why we written like this. P1 by ρ1 V1 square by 2G plus GH1 is equal to so on and so forth. This is one form. We can also write in another form also, Bernoulli's theorem. Adenti in terms of energy. In terms of energy, that is the total sum of pressure energy, kinetic energy and velocity, gravitational energy is equal to constant. Ela chudandi okasari. The same equation I can write as in the form of capital P plus rho V square by 2 plus rho GH is equal to constant. Same Bernoulli's theorem ani ఏమని రాయొచ్చు నేను? I can write as total sum of ఇదేంటి రాసాను? P by rho G అంటే ఏంటి? Total sum of pressure head, V square by 2G, velocity head, gravitational head H or potential is equal to constant. లేదా the total sum of pressure energy అంటే energy per unit volume, pressure energy per unit volume, pressure energy అంటే that is P plus kinetic energy per unit volume rho V square by 2 అలాగే gravitational energy per unit volume that is rho GH is equal to constant. So this is how you can express the Bernoulli's theorem. This theorem or this principle you can apply in the venturimeter. That is the next topic. Application of Bernoulli's theorem in venturimeter. That means unequal cross section of area of pipes లో వాటర్ ఫ్లో అవుతున్నప్పుడు వెలాసిటీస్ ఎలా ఫైండ్ చేయాలి, అలాగే ఏరియాస్ ఎలా ఫైండ్ చేయాలి, వెలాసిటీస్ ఎలా కట్టాలి, ఆల్ దీస్ ఆర్ యూజ్డ్ బై Bernoulli's theorem. ఈ Bernoulli's theorem అప్లికేషన్స్లో మనం వెంచరీమీటర్లో మనం చూడొచ్చు. ఓకే, నౌ దిస్ డెరివేషన్ ఐ థింక్ యూ అండర్స్టూడ్ వెరీ వెల్. దిస్ ఇస్ 8 marks question IPE, very important question. This is part 1 in fluid mechanics or mechanical properties of fluid. In part 2 we will be dealing about the application of Bernoulli's theorem, that is in aeroplane wing, how it is there, how it is applied. Okay, and also in cricket also you can see in spin bowling how the Bernoulli's theorem is applied. Okay, not only these, we will be applying in venturimeter also. Okay, all these things I will be dealing in the next part, that is second part of mechanical properties of fluids or fluid mechanics. Okay, right.